Hey everyone, welcome back to another explainer brought to you by Forge College. Today we're tackling event syntax and declaration. So if you're on a journey to master smart contract development, you're absolutely in the right place. We're currently working our way through the events and logging in Solidity module of our Solidity from Zero track. Now, if you remember our previous lesson, Introduction to Events, we talked about how events act as this highly efficient off-chain wind-up mechanism to signal the outside world. Really cool concept. But, the Ethereum virtual machine doesn't just do vibes. It needs strict, specific instructions. So today we're putting on our hard hats and analyzing the exact engineering blueprint of event syntax.
All right, let's just quickly breeze through our schematic index for the day. We've got the anatomy of an event, the power of indexing, the somewhat quirky hashing of dynamic types, going ghost mode with anonymous events, and then we'll tie the whole shebang together with real-world smart contracts.
Okay, Section 1, the anatomy of an event. Let's dive in.
So conceptually, logs are just a beautifully gas-efficient way to say, hey, a token was transferred, right? But in practice, the syntax rules are actually incredibly strict. For starters, events literally must be declared at the contract scope. That means they live right at the top level of your contract, not tucked away inside some function. You have to tell the compiler the exact parameters you plan to broadcast right from the get-go.
Declaring an event is pretty straightforward, though. It just takes 3 simple steps. First, you use the lowercase event keyword. Second, you give it a name. And by convention, we use Pascal case for this, like token transferred with capital letters. Third, you open your parentheses, list your parameters, and then finish it all off with a semicolon. Now, I really want to emphasize something absolutely crucial here. Events are not functions, okay? They have no curly braces, no visibility modifiers, and they definitely do not return values. They are purely declarations.
To give you an idea, here's what that looks like in its absolute simplest form. Event foo, followed by its parameters, an address called from, and a 256-bit unsigned integer called value. Now you might notice the word indexed sitting right there in the middle. We're going to get to that in just a second. But this single line of code, that's literally all you need to map complex on-chain activities to readable off-chain logs.
Moving right along to Section 2, the power of indexing. Think of these as high-visibility neon sticky notes for the EVM.
Take a look at this giant number here, 3. 3 is a magic number when it comes to Solidity events, and it's a hard, non-negotiable limit. You can only have a maximum of 3 index parameters per event. It's kind of like the EVM operates as a budget airline with ridiculously strict minimalist luggage limits. If you try to bring a 4th index parameter on board, the compiler is going to stop you right at the gate and throw an error. No way around it. So why exactly 3? Well, it all comes down to basic EVM architecture math. The EVM log structure provides exactly 4 slots, which are called topics for searchable data. Topic 1 is pretty much always consumed by the event signature hash. That's just how the network knows which event was actually fired. So that leaves exactly 3 remaining topic slots for your index parameters, topics 2, 3, and 4. Any parameter that you don't specifically label as indexed just gets tossed into the unindexed data blob, which, hey, is much cheaper on gas, but it absolutely cannot be quickly filtered or searched by off-chain tools.
All right, Section 3, hashing dynamic types.
Now, this is one of those common gotchas in the EVM blueprint. Say hello to the shredder, specifically the KEK 256 cryptographic hash function. Remember how a topic slot is strictly 32 bytes long? Well, a long dynamic string literally isn't going to fit in there. So if you declare a string parameter as indexed, Solidity basically takes that text and runs it right through KEK 256, shredding it into a uniform 32-byte hash. This means if you index a string like transaction successful, your off-chain app reading the log is just going to see this random-looking hash. It cannot reverse the math to recover your original text from the topic alone. It is a one-way trip for sure.
Next up, Section 4, going ghost, anonymous events.
So, a standard event uses up topic 1 to broadcast its signature, right? But an anonymous event? That is straight up ninja mode. If you tack the word anonymous onto the very end of your declaration, the EVM intentionally drops the signature from topic 1 entirely. That means the topic array will contain only your indexed values. It definitely saves space, and it could technically let you squeeze in an extra parameter if you desperately need it for custom filtering. But there's a massive trade-off here. Standard blockchain explorers and indexing tools are going to have a much harder time figuring out what event was just fired.
Let's head into Section 5 and look at some real-world smart contracts. Let's lock in these engineering specifications so we're absolutely clear on how this applies. You've got your absolute max of 3 index parameters per event.
Index dynamic types, those turn into unreadable Ketchuk 256 hashes. Indexed value types, like addresses, those store nicely as a readable 32-byte word. And finally, anonymous events just drop the signature entirely. The big takeaway here is that every single one of these choices directly dictates what the outside world actually sees when your contract runs.
Let's analyze a couple of real-world snippets to see this in action. The first one is a classic ERC-style transfer event. Event token sent taking an index from address, an index to address, and a value. Notice how from and to are indexed here. That allows a server-side indexing service to instantly filter millions of logs just to find transactions involving your specific wallet address. But the actual value? That's left unindexed in the data payload. Now look at the second one. It's a private, compact log, event audit log with an index 32-byte ID and a string message left unindexed so it wouldn't get hashed into oblivion. Plus, they made it anonymous to create a super compact internal logging pattern.
So to put it simply, here is the absolute best practice you should take away from this. Always index your stable identifiers, things like addresses or specific IDs, because that's exactly what your off-chain consumers are going to use to search and filter your events. But keep your verbose, descriptive payloads, especially text strings, unindexed in the standard data portion so they remain easily readable. You really have to design your events around the specific filtering needs of your front-end tools and block explorers.
Well, we have thoroughly examined the blueprint today. But here's the real question. How do these declared events actually look when they're emitted live on the blockchain? Like, what does that transaction receipt actually look like? We are going to tackle exactly that in our next lesson, emitting events and transaction logs. To continue this journey, be sure to head over to forge.college and jump into the rest of the Solidity from Zero track. This explainer was brought to you by Forge College. Keep learning, keep building, and I'll see you in the next one.